Hey y'all, semester exam tomorrow. I was really hoping to not have to make a video, but had quite a few people asking. I am recording it during lunch, so you may hear crinkling of bags and stuff or whatever I'm eating, and I apologize. Okay, here we go. So it's 1, 2, for 1 it should be 1, 2, and 3. Given the tables, find the zeros. Zeros are your x-intercepts. So zeros are x-intercepts. They're when your y equals 0. So in an ordered pair, it would be something, comma, 0. Okay, so if I'm looking at this table, -6, 0, this is a 0. 3, 0 is a 0. So we got -6 and we have +3. On this one, we have -4, 0. That's a 0. I'm telling you there's one more 0 on this graph. You might not be able to see it. If you plug this in your calculator, you could always use your quadratic formula squiggly line. Or, look y'all, in your y's, it's positive, positive, negative, negative, positive, negative. What do you notice? Well, first of all, oh, I did it wrong. Nope. Take it back. If we are switching between positive and negative, from here to here, -4 to +6. If we switch from positive to negative, we have to go through 0 in between that. Well, what's between 0 and 2? 1. So we also have another 0 here, so it's -4 and +1. I'll explain it again on the next one and not mess up this time. So we have one right here at -6, 0. That is a 0. Now I'm looking at our y-axis. We got -4, -6, -4, +6. Right here, we switch between positive and negative. To go between positive and negative, we have to go through 0. So what's between -1 and 0? -1. So this one's -6 and -1. All right, for number 4, it says given f of x equals 2x plus 5 squared plus 4. What is the value of f of 10? This is a row 1, row 2 question for your calculator. Row 1, row 2. I'm going to go ahead and plug that in. Remove all my junk. So we are going to put in f of x equals parentheses 2x plus 5 squared plus 4. And the next row I'm going to put f of 10. My answer should be 629. All right, number 5 says, what is the domain and range of the following graphs? Remember, for domain and range, first of all, it's doctor, X, Y, and it's robot, dealer. Okay, so I'm going to start with domain on this one. Domain are your X values, and domain, which is our dealer here, goes from left to right. Well, if I'm looking here, there's nothing actually stopping this graph from going to the left. It has an arrow. It's going to keep going. Same thing over here. Even though this is only part of the picture I can see, there's an arrow here. It's going to keep going to the right. So there's nothing stopping it from going left or right. It's just going to keep going. We call that all real numbers. For my range, those are your y values. So domain X, range Y. Range goes from bottom to top. Well, on this graph, the lowest we can go is right here at -9. And if I'm going here, even though that's where the picture stops, there's an arrow here. It's going to keep going up. So I can be -9, or I can be bigger than that. Our math way of saying I can be -9 or bigger is y, because its range, is greater than or equal to -9. Okay, same thing on this one right here, domain, left and right. Well, if I'm looking here, even though the picture stops here, there's an arrow, so it's going to keep going this way. Same thing on this one, it's going to keep going this way. There's nothing stopping it from going left and right. Our domain is all real numbers. For my range, this time we have a maximum. We have a highest point we can go to. The highest point we can reach is 3. And if I'm looking here, there's nothing stopping it from going down. It's going to keep going down. So we can be 3 or we can be less than 3. Our math way of saying that is range is our y is less than or equal to 3. All right, same thing. It's asking us for domain and range. The only thing that's different is they gave us an equation this time. So I have to go and plug that equation into my calculator. They said h of x equals 2/3, parentheses, nope, not parentheses, x squared minus 12x plus 2. All right, here's my picture. If I'm scrolling here, is there anything stopping this graph from going left and right? No. My domain is all real numbers. For my range, I'm going to go back for a second, hit the house button to reset. This one, does it have a maximum or a minimum? It has a minimum as a lowest point that we can reach. And when we're talking about range, are we talking about our x or my y? Hopefully you said y, so it's -52. So we can be -52, or we can be bigger than that. Our way of saying that is y is greater than or equal to -52. On the bottom, at least here's what I had my kids do, is just sketch an example. I want them to be able to know, looking at a graph, how to know if it has 1 0, no zeros, or 2 zeros. It has 1 0 if it hits your graph on the x-axis once. So that could be an example. You can even have one that's like this. It doesn't matter. They're both hitting the x-axis one time. For no zeros, you should not hit your x-axis at all. So you can have a graph that's like this. You can have a graph that's like that. They're not going to be on the same graph. I'm just showing that you could have one that's regular, you can have one that's reflected, and facing the opposite direction. For 2 zeros, it has to touch your x-axis 2 times. So whether it's upside down or whether it's facing up, it should only be hitting your graph, your x-axis, twice, because zeros are x-intercepts. My God. Okay. A ball was thrown from the ground. So we're literally starting on the ground. Here's the ground. Was thrown from the ground, and the path of the ball was recorded in the table below. So the graph is saying it's starting at 0, then it's going up, 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 and then it's starting to go back down. 6.4 is smaller than 6.5. Oops, sorry. And then it starts to go back down. It's going to be something like that. This is not a straight line. It's not linear. It's not exponential. This is quadratic. They want us to write an equation that best represents the path of the ball. If I give you a table and I'm asking you for an equation, we're going to go use one of our regressions, our squiggly lines. For this one, because it's quadratic, we're going to use the one that's y1, squiggly line, ax1 squared, plus bx1 plus c. So you would go plug this whole table into your calculator and then plug in your cheat code and get an answer. I am so sorry I'm not plugging it in. I don't want to. I should do it, but I don't want to. It should be y equals negative 0.73 x squared plus 4.37 x plus 0.09. Okay? Simplify the following. I'll give you a whole bunch of square roots. Okay. Am I done chewing? Maybe? Okay. So 120. Things that multiply to 120 are 1 and 120. Let's say I don't know some other things that multiply to 120. I'm just start plugging it into my calculator. So I would do 120 divided by 2. Oops, I skipped 2. So we know 2 and 60 works. I tried 3. 3 and 40 works. I'm going to try 5. 5 and 24. I'm going to try 6. 6 and 20. I'm going to try 7. I'm going to try 8. 8 and 15. Try 9. Nope. I'm going to try 10. 10 and 12. Let me add that over here. 10 and 12. I think that's it because 11 doesn't work. And then we repeat. So here are all the things that multiply together to get. Did I skip one? Did I do 4? Y'all, how did I skip 4? It's in it also 4 and 30. Okay. So anyway, there's all of our things that multiply together to get 120. Which one's our biggest perfect square? It's just so loud out of that hallway. Isn't it 4? 4. So it's square root of 4 times square root of 30. If I plug square root of 4 in my calculator, we would get 2. If I plug in square root of 30, we get a decimal, so we're going to leave it alone. Here's my final answer. All right, I'm going to do the same thing with 75. We know 1 and 75. If I don't know stuff, I can start plugging in my calculator. I'll tell you 3 and 25. I'll tell you 5 and 15. What's our biggest perfect square? 25. So that would be square root of 3 times the square root of 25. The square root of 3 gives me a decimal, so I'm going to leave it alone. The square root of 25, if I plug it in, gives me 5. All right, I'm going to make my list for 180. This one's quite a bit longer. 180, 2, 90, 3, 60, 4, 45, 5, 36, 6, 30. Let me see what else. 9 and 20, 10 and 18, 12 and 15 are all things that multiply together to get 180. Well, my biggest perfect square, if I'm looking at this, it looks like is 36. So this is the square root of 5 times the square root of 36. If I plug in the square root of 5 in my calculator, I would get a decimal, so I'm going to leave it alone. Square root of 36 is 6. All right, now I need things that multiply to 294. We got 1 and 294. We got 2 and 147. I got 3 and 98. I got 4, nope, 6. Yeah, 6 and 49, 7 and 42. I also got 14 and 21. So if I'm looking here, our biggest perfect square is 49. So this is going to be the square root of 6 times the square root of 49. The square root of 6 would give us a decimal, so I leave it alone. The square root of 49 is 7. I have to make 3 separate videos, one for each page, because, holy. All right. Moving on. Find our solutions. So, first thing we're going to do is we have x plus 5 squared equals 35. We're trying to get the x by itself. The opposite of squaring something, square root. So I'm going to square root both sides. That makes this disappear. So we're going to have left x plus 5 equals, remember if you square root, it should be positive or negative, square root of 35. I need things that multiply to 35 to see if I have to simplify that. I have 1 and 35. I got 5 and 7. What's our biggest perfect square? 1. If our biggest perfect square is 1, it's already simplified, and I'm going to leave it alone. So now we just need to get our x by itself. The opposite of plus 5 is minus 5 to both sides. We would get x equals negative 5 plus or minus the square root of 35. Same thing with this side. If we want to get x by itself, the opposite of squaring something is square root. If I do it to one side, I have to do it to both. That makes our square disappear. We got x minus 2 equals positive and negative square root of 20. Now we have to check and see if 20 is simplified. So 20, we need things that multiply to get 20. You know, 1 and 20, 2 and 10. We know 4 and 5.
Can you show me the draw that you submitted the ticket for?
Yes, I can.
So I have to take a picture of it.
Yeah, when they all ran in here, they all crowded into the corner. So what they did was,
Okay.
they broke this part.
Yeah, we'll just take a picture screen. Just so they can see what kind of supplies to bring. Okay, thank you very much.
Thank you.
Want me to plug it on?
Yes, please. Sorry, I can't pause the video, or I have to start over. Our biggest perfect square is 4. So this is the square root of 4 times the square root of 5. So we have x minus 2 equals positive and negative. Square root of 4 gives us 2. The square root of 5 gives us a decimal, so we leave it alone. Now we can work on getting x by itself. The opposite of minus 2 is plus 2 to both sides. So we're left with x equals 2 plus or minus 2 square root of 5. This one says, write a quadratic expression that can be factored using a difference of 2 squares. Remember, difference of 2 squares means dots. Dots means 2 parts. They're perfect squares. So 2 parts, perfect squares, no x term, subtracting. So, for example, it could be like x squared minus 9, because x squared is a perfect square, x times x. 9 is 3 times 3. We're subtracting. There's no just regular x term. This is a dot. For example, 64x squared minus 100. Because this would be 8x and 8x. This would be 10 and 10. We're subtracting. That's an example of a dot. All right, scooting down. Solve the following for the letter that is indicated. We are solving for R. Okay, when you're solving equations, we are doing opposite operation. Okay, so we need to get our R by itself. Here's what this equation looks like right now. We have A equals pi r squared, which is the same thing as saying A equals pi times our radius squared. Okay, so we need to do opposite operations. What do we need to get rid of? Well, we need to get rid of the pi. The opposite of multiplying by pi is dividing by pi. What else do we need to get rid of? Well, if I want r by itself, what's the opposite of squaring something? Square root something. So our answer would be r equals, technically it'd be positive or negative, because anytime you use square root, it's positive or negative, a over pi. Same thing for this one. They said solve for t, and it's I equals PRT. So I equals P times R times T. We want to get T by itself. Well, if I'm doing that by opposite operation, the opposite of multiplying is dividing. And we want to get rid of P and R. If I do it on one side, I have to do it to the other side. T equals I divided by PR. There's the area of a rectangular rectangular garden is 3x squared plus 7x plus 2. What are the length and the width of the garden? If they give you an area and you are trying to solve for your sides, you are doing your big X's. So here's my box, T, X. So for my box, we're going to put our 3x squared here. We're going to put our plus 2 here. As a reminder, this is your A times C. This is your B. Remember, A is in front of x squared. B is in front of your x. C is your constant, your number of bits by itself. So I'm doing 3 times 2 is 6. My B is 7. So we need things that multiply to 6, but add up to 7. So for example, 2 times 3 is 6, but they do not add up to 7. 6 times 1 is 6, and 6 plus 1 does get us 7. So that's what goes in these two boxes here. It does not matter which box you put them in. So I'm going to put my 6x here and put my 1x here. Now, I need to figure out how I get 3x squared. Well, 3x squared is going to be 3x times x. I cannot put my 3x here. Here's why. 3x times, there's nothing that'll give me 1. If I put it here, though, 3x times 2 will get me a 6. So we got 3x and x. And like we just said, 3x times 2 gets us a 6x. X times 1 gets us a 1x. 1 times 2 gets us 2. We are good. Our two sides, our length and our width, are x plus 2 and 3x plus 1. All right, sliding down to the last one for this video. What is the greatest common factor of or GCF of the polynomial shown below? And I gave you 4a x squared. I'm going to put xx minus 16x. First of all, to check my numbers for a GCF in my calculator, we're going to put lowercase GCF. parentheses, 4, comma, -16. Because at least my calculator can tell me for my letters, not so much so the variables, but it can at least help us with our numbers. GCF, we got 4, comma, -16. Our GCF is 2. But I didn't even put 4. Y'all just let me do that. 4. It should be 4. So our GCF is 4 for the numbers. Is there anything else they both have in common? Yes. They both also have an x in common. It can't be x squared. They both don't have 2 x's. They both have 1 x though. Our GCF is 4x. See you in the next one.